Hi, I'm Nick Beaton from MinDet, and this is prototype number 4 explained in 3 minutes. MinDet couples a robotic microscope with artificial intelligence to identify minerals in process streams. MinDet is easy to use. A process slurry sample can be decanted directly into a cuvette and loaded into the device. The sample does not have to be a process slurry. It could be any material ground to a top size of about 400 microns. Turn it on, tap on the start button, and the automated cycle begins. The robotic microscope starts imaging the sample and separating out the particles, and then each particle is processed by the AI to identify the minerals. Now let's have a look at the data that MinDet captures as it processes the images. This is the main summary tab, and it is updated cumulatively as each image is processed. Starting on the left, you can see the particle size distribution, the mineral distribution in each size fraction, the overall grade of each mineral in the sample, and the last one is the overall grade of the target elements in the sample. The Measurement History tab records the number of particles for which minerals have been identified. MinDet needs to identify a minimum number to get an accurate reading. Sometimes the number of images has to be increased if a mineral is not abundant in the sample. The Image Browser tab is the gateway to the images that are generated as the device is operating. These images can be stored locally or on the cloud, and they can be reprocessed with an updated AI algorithm if required. I'll come back to this tab in a moment. The Liberation tab is a treasure trove of data. This graph shows the distribution of the mineral in each size range that has been liberated. The user can adjust the minimum liberation and do that for each mineral. Toggle the mode to cumulative and the graph shows the full distribution of mineral mass across the size range, as well as the percentage of the mass that has been liberated to the nominated degree. Adjust the top size and MinDet calculates the maximum theoretical recovery. The graph on the right shows the mass distribution of the mineral that has been liberated more than the nominated degree. There's a separate curve for each size fraction. Let's go back to the Image Browser tab to see how MinDet gets the data for this analysis. You'll see here that MinDet can identify not only particles that are fully liberated, but also particles that enclose unliberated grains of minerals. Importantly, MinDet can differentiate between the two. So regardless of whether it's a fully liberated particle or a partially liberated grain, MinDet can identify the mineral species and calculate the mass. MinDet will set the new standard for quantifying minerals in a process slurry, and that data is the doorway to increasing metal recovery. Okay, that was a pretty quick look at prototype 4. If you want more information, there's an email address below. It would be great to hear from you.